In this session, we're going to look at how we can create arrays dynamically instead of statically. The process of creating a dynamic array is pretty straightforward, so let's take a look. We're going to use the reallocate function, and we're going to use this one because remember, this one allows us to grow the size of the dynamic memory that we have allocated. So that's going to be pretty useful for us as we want to add new array elements. So we're always going to have to start by declaring a pointer to that dynamic array. So here we're saying we're going to have an integer array, and our pointer is going to be called iPointer, and it's very important when we initialize for dynamic arrays that we set it to null as we declare it. And the reason for this is because in order to use reallocate, we can use this to declare a brand new space in memory, or we can add on to an existing one. So if the pointer is null, it's going to create a new space. If the pointer has a valid address, it's going to add to the space or expand that. So let's take a look at what we have here. Our reallocate function requires the pointer, so right now it's null, and we have the number of values we want times the size of each one. So a number of values, maybe we want 1. And the size of an integer would be dependent on the platform you're using. So this is going to define the total number of bytes we need. Our pointer is null right now, which tells reallocate that we're asking for new memory. It's going to return a pointer to an integer, and it's going to assign that to iPointer. Next thing is we always need to make sure that the memory was allocated properly. So we're going to check our pointer to see if it's null. If it's null, there was a problem. If it's not null, it means we now have that block of memory reserved somewhere. We reserved to hold one integer. So iPointer is pointing to that one space. Then we can ask the user to enter some information for us, or we can assign a value. So here I'm going to use a loop here. So I have I, let's say it's 0 right now, and that gets assigned to element number 0 inside our array. So that's going to put a 0 in that first element. Next thing says we're going to repeat steps 2, 3, and 4 for each additional element we want to add to our array. So if we come back to step 2 again, iPointer now has a value. It's pointing to this block that we have that's storing one element. So when we reallocate, we're going to tell it that pointer and say, now I want 2 bytes. So 2 values times the size of each one. And what it's going to do is going to go off and say, okay, I'm going to add a second element for you. And I'm still going to point to the first element. So iPointer will still point to that first element. I check to make sure it was successful because sometimes it might fail for whatever reason. And then I'm going to assign a value. So if I'm looping, I is now going to be 1, and I'm going to store that there. And I can go back and repeat these steps as many times as I want, each one adding a new 1, or even I could say I want to add 2 more. The thing to remember is when we're doing this calculation here, it's the total number. So right now, for that last declaration, I would have 1, 2, 3, 4, 5 times the size of an integer that I was reallocating for. So this number of values is growing each time. It's not the number of new elements, it's the total number of elements. So let's make a note of that. It's important that you remember that it's the total. So let's look at a block of code that will actually do that for us. So here we're looping from I equals 0 to I is less than number, and we're incrementing I each time. Here's our reallocate, our pointer, so we're assuming the first time the pointer is null, and we're using I as the number of elements we have, and we're multiplying that by the size of an integer to get the total number of elements. So right now I is 0, we add 1 to it, so 1 times size of an integer, we're going to allocate 1. It's going to return a pointer to an integer, and the pointer is going to go there. So after that first one, we will have memory allocated for 1. iPointer will be pointing to there, and Here we're saying assign I to I pointer plus an offset of 0. So the first element, we're going to store I. I is 0, so we're going to store 0 in there. Next time we come through, so I is now equal to 1. Let's say 1 is less than number. We're going to reallocate with our pointer, which is pointing to this block right here. I is now 1, so 1 plus 1 is 2 times the size of an integer, so now we need space for 2 integers. So it's going to add 1 to it. Assuming it was successful, it's now going to store 1 in element number I pointer plus 1. So in this element, it's going to store a 1. Let's go through one more time. So now I is equal to 2. Let's say number is 3. So we're still less. We're going to reallocate with our pointer. I is now 2, so 2 plus 1 is 3 times the size of an integer, so we need space for 3. It adds on. It verifies that that memory allocation was successful, and now we're going to write a 2 into element number 2. So element number 0, element 1, element 2, we're going to write a 2. We come back. If number is 3, I is now 3, it fails the test and falls out. Now, just like with other data types, we want to be able to pass our dynamic arrays into functions to use or to change. So let's take a look first at how we can pass it in to use those values. So a typical application might be to print the values that are in the array. So here we've got a call. My function's called print array. We're going to pass in the pointer to the data, and we're also going to tell it how many elements. So our first variable, or our first parameter, is a pointer. So here we need to tell it to expect a pointer to our array of integers. And here we're going to tell it how many elements we have in that array. Then we go in, we have a loop, and we're going to loop for I equals 0 to less than the number of elements, increasing I each time, and we're going to print an integer value by using our contents of, and then specifying the beginning of our array with the pointer plus the offset in. So if I is 0, we're going to print the contents of element 0. If I is 1, we're going to print the contents of element 1. If I is 2, we're going to print the contents of element 2. And that's going to continue until we've printed each of the elements in that array. So we're not changing anything in the array here. We're simply passing it in and printing things out. But what happens if we want to change things inside that array? Then we're going to have to do things a little bit differently. So we have two methods. One, we can pass in the address of the array and return it. And remember, because we're adding to things or changing things, particularly if we do a reallocate, it might move that. So it's very important that we pass back that modified address. Or we can pass in the address of the pointer. So let's take a look at the first method first. So here we have a function called changeArray, and we're going to pass in the pointer and the number of elements. So if we have our array and we have our pointer to that array, we're passing in, this is our data pointer, and our number of elements here would be 3. That return value is being assigned back to the pointer. So we need to specify in our function declaration line that we're getting a pointer to an integer, we're passing in a pointer to an integer, and the number of elements. So here we're going to loop on I. From I is less than the number, so we've got 1, 2, 3 things here. So we're going to loop from I equals 0 to 2. And here we have a reallocate. We have our typecasting here so that we can assign that array pointer, our pointer that we're allocating, and I plus 1 times the size for the total number of bytes we want to reserve. So I starts off at 0, so we're going to reserve enough for 1. We allocate, we assign it to our array pointer, we make sure it's not null, and we write a value into that array. So we're writing a 1 into this block. We loop back, I is now 1, it's less than 3. We allocate or reallocate in this point because array pointer has something in it. Now we're getting more elements, so I is 1 plus 1 gives us 2 times the size of an integer. So we're expanding to 2 elements now. Assuming it's successful, we write a 2. Actually, the first one wrote a 0, and this one now writes a 1. We loop one more time. So I is now 2. 2 is less than 3, which was our number. We reallocate for enough space for 3 elements. We write a value in there. In this case, it will be 2. And we follow the loop, and then we return the array pointer. So the reason that we need to return this pointer is because if, for example, when we added this third element, there wasn't enough space in the original place the block was located, and it moved it down to here for the 3, then the pointer now has a different address stored in it. So we need to make sure that that value is returned, so when we try to access our array up in main or wherever the calling function is, that we now have the address of this new block. The second method is a little bit more interesting. Here we have a function called changeArray2, and here we're passing in the address of our pointer plus the number of elements. So if we look at our function declaration here, we are not returning the pointer this time. Our array name or our function name is here, and here we have 2 stars, 2 indirection operators. So what this is saying is we're getting a pointer to a pointer. So that's a kind of unique little thing. A pointer to a pointer. So how do we use that pointer to a pointer? We have a regular passed by value thing here. We're going to loop for I is less than that number. So if we use 3 again, here we have, and I've called it pointer address, just to make it clear that I know I'm pointing to an address instead of pointing to an array or pointing to an integer. So here, the contents of my pointer to an address, which gets me to the address, or a pointer. Remember, that's all a pointer is an address. Here in my reallocate, I'm saying that address or that pointer, here's my size. So the only difference is now, because I have a pointer to my address, I need the contents of to get to the actual address. So again, this is my address. By putting that contents of there, it gets me to the address. Here, in my check, I'm checking the pointer, so I need the contents of the pointer's address. And here, I'm saying the contents of the pointer's address gives me my address plus my offset, gives me where I am in the dynamic array, and then this one says write I to that location. So the only difference here is we have added, everywhere we used the pointer before, we're using the pointer address, and we've got an extra level of indirection there. So it's a little bit tricky, but it's really powerful. Why would you use this? Some people don't like returning the pointer, and they would rather just have one value that they're working with. So let's do a quick recap of the process. First, we need to declare the pointer. Then we're going to go into a loop that adds each element in our dynamic array one by one. We're going to use reallocate to reserve the memory for n elements. So usually it would be 1 at a time if we're doing this, but we could do 2 at a time or 3 at a time. If the memory is properly allocated, we're going to populate the element or elements. If it's not, we're going to display an error message, and we're going to continue that process until we have added all of the information we want to our dynamic array.